basically just gonna be me and you, because he already did all the homework and everything, and he never pays attention. You got this? This is me and Christian right here. All right, Christian.
Yes.
There we go. Okay, good. All right. From there. Let's see. I gotta move my switch. It's annoying. All right, so let's go through and do the notes. So, fundamental theory of calculus. This is one of the ones that will always be on multiple parts of the free response of the AP exam. Always. So, part one, fundamental theory of calculus, and part two. These two are both always on there. So, here, let f be a function that is continuous on a closed interval from a to b. Let the function I be defined by the function I, capital I, notice, here of x is going to be from a to x. So this is my lower bound, this is my upper bound of f of t, and if you notice this is t dt, right? Okay, so we're going to change it up. So right here, when we have this, has a property that is continuous and differentiable on that same, it's going to turn into, for all x in that it's going to turn into, because what's going to happen is the integration and the derivative should counteract each other. So as we do this, it should look like from here, okay, we're actually substituting whatever this is. So when we do this, it's going to plug in for this in the top, and then this is going to cancel. If you notice it, the lower bound goes away. Okay? And so for this one right here, showing the steps, because it's already done, but still. From this, it actually takes my derivative of the integral and it replaces, so whenever we have this right here, because this is going to plug into my bound right here, and so it's going to change my variable from t to whatever I have up here, and then it's going to cancel out all of this to just be the function of square root of x plus 1. Okay? Same thing goes for the bottom. So, same thing goes to the bottom. From this one right here, again, in my function of ds, I'm replacing my s's with x's. So, instead of s third, this is going to be x third, if you guys can't read this very much. Minus 1 over, that's going to be 2s squared, changing it into 2x squared, plus s, which is changing to plus x, and then my plus 1. So this replaces, it's kind of like multiplying and dividing at the same time. Because is it multiplication just the same as dividing by 1 over that number? No, division is the other way. No, division is the same as multiplying by 1 over that number. So we can cancel it out either way. So multiplication and division will undo each other, and derivative and integral will undo each other in this. Alright, so for this one right here. So for those people playing along with us at home, i.e. Christian, so this is in terms of what variable? What's the variable? It's the variable is it's t, right? So that's telling me I'm replacing the variable t with this function here. Alright, what would it look like?
3x squared plus
Okay, hold on. Loud and clear.
3x squared plus 1.
Ooh, you missed a little bit.
Oh,
Square root of
3x squared plus 1.
missing one more thing.
6x.
E to the t, but it's not e to the t, it's e to the
e to the 3x squared plus 1 plus
plus.
3x squared plus 1.
Yeah. So in this sense right here, I have replaced this right here. I put parentheses around it, but it's a good thing, especially, it's a good habit to get into, especially if this right here is a minus sign. So whenever I'm evaluating, I plug it in using parentheses to try to do my best to keep myself in order. If I want to simplify it, I will. We good? Now, this one right here, part of my thing, what's wrong with this one? Don't you shrug your shoulder at me. What's different? One of these things is not like the others. One of these things will burn in hell. Look at this one here. Look at these ones here. Look at what I have here. There we go. My lower bound is my variable. Okay? Using this right here, I could actually change my bounds. And that's going to be important. So I could change my bounds. And this is going to be something that you're going to have to do later on, especially when we're talking about area under a curve. So I could change this bounds, but I would actually have to do one thing. So if I go my bounds of x cubed to 5, I'm switching the direction, right? So the bounds from A to B, so if I have my number line here from A to B, how would I tell it? Because this is my A and this is my B. So to change this to go from A to B, but instead go from B to A, what would I need to do? Especially if I'm talking about velocity here. No? If it's, how do I get a velocity to go backwards? That's what we're doing. So derivative, integration is the same as the antiderivative. But if I'm going forward, what type of velocity is that? It's positive. Okay, so if I'm going backwards, my velocity must be negative. So that's what I'm going to do. So I'm going to change this to now be a negative. So negative, and then so that's going to be important, because whenever we're actually doing, like the problem that we had the other day, we had a negative area, right? And we had a positive area, right? And with those two, the negative and the positive, what happened to those? Didn't that give me 0 on the problem? But is that true? Is that really true, that the area was 0? No. And so by doing that, we're going to have to manipulate that to be able to. So if I have a curve, if I have a curve that goes from here to here like this, so if all this is negative, I would actually have to flip this piece right here because let's say for instance I am using a paint. Okay, let's say I'm in some type of graphic design and I'm painting something, right? So I don't have zero paint that I'm gonna have there. I'm gonna have whatever the surface area is here, add the surface area here, right? But is this negative, right? So I would have to change this to be a negative, negate my integration of this part here, right? And then I would add my integration of this part over here. So that would be my total area. And so that's how we're able to manipulate this to actually get what it is instead of my negative canceling out my positive. Does that make sense? Yeah? Okay. So now by doing that, now I could actually look at my function now as t4 plus 1 to the 1/3 dt. So I'm changing the variable. Oi! Go to class! Stop making out there! It's disgusting!
There's no chance.
I know, right? Yeah, it's gonna be on the camera too.
Oh, it's
Yeah, it's on the, we'll post it on TikTok later. Anyway, alright, so let's go ahead, and so now I'm replacing the t with my x cubed. And again, I like putting in my variable in parentheses to make sure I do this correctly. So it's going to be parentheses, and t is replaced with x to the 3rd, and that t is being raised to the t is being raised to the 4th power plus 1 close raised to the 1/3. Does that make sense? Christian? Yeah. Okay, so do you understand this part right here of changing this and then making it a negative? So from here, this will undo this, but then I still have to change sign. Because I changed the bounds, going from one direction to the other direction instead. Yes? No? Maybe? Okay. Alright. I think that one's it for today. Yeah. Because part 2 we'll do tomorrow. Okay, you guys could actually start doing some of the worksheets. So make sure you like, share, and subscribe.